In this video, we will try to solve few problems related to the inverse Fourier transform. Like the first question is given and it is asked that find the inverse Fourier transform of x omega is equals to j omega plus 3 divided by j omega plus 1 whole square. To solve that, we need to know the following Fourier transform first. So like these are the few properties that we have done in our previous lectures, and here we can write them straightforwardly, like Tn e raised to minus at ut is equals to 1 over j omega plus 1 whole power n plus 1. Like this is the in frequency domain and that one is in time domain. Similarly, if the power of t is 1, e raised to minus at ut, so this is in time domain and it can be written in frequency domain, that is 1 over j omega plus 1. So n is 1, so that is why 1 plus 1, the answer is 2. Similarly, we can write e raised to power at ut is equals to 1 over j omega plus 1. So using these properties, we can further simplify this question and we can calculate what is the inverse Fourier transform. So like here, so we can rewrite this j omega plus 3 in this format, j omega plus 1 plus 2, and then we can separate them, j omega plus 1 divided by j omega plus 1 whole square plus 2 divided by j omega plus 1 whole square. And then similarly we can use this previous identity, we can calculate the inverse Fourier transform of these equations, like the inverse Fourier transform of that part and the inverse Fourier transform of this portion, which can be equals to e raised to power minus t ut plus this is to 2t e raised to power minus t ut. Using the previous similarities, previous properties, like how can we write the frequency domain signal into the time domain signal? We can convert this into the time domain signal. So you can take further common and you can simplified form of that signal in this format. The second question is that find the inverse Fourier transform of x omega is equals to 5 plus 2 j omega divided by j omega whole square plus 5 j omega plus 6. So again you need to use the same identities and then you can use those identities, you can simplify that one. But before that you need to simplify this format so that you can have the same format as we have used in our previous question. Like we can take the factor of the denominator, and we know the factors are 3 plus j omega and 2 plus j omega. So these are the factor of the denominator, and then we can write 1 over 3 plus j omega plus 1 over 2 plus j omega. And if you further simplify these, you can write like this, like take the LCM of these denominator and then the first it will multiply like 1 with 2 plus j omega and then 1 with 3 plus j omega, then it is simplified to that one, and then this is again simplified to this one. So you can see this equation and this equation is same. So that is why you can implement the previous properties from time domain to frequency domain on this equation. Like you can say that it can be equals to e raised to minus at ut can be equals to 1 over j omega plus 1. So that is why you use this property in this format, and then you can calculate what is the inverse Fourier transform, that is x of t e raised to minus 3t ut plus e raised to power 2t ut, which is further simplified in this format. The next question is that you need to calculate the inverse Fourier transform of x of omega, which is equals to omega square plus 21 divided by omega square plus 9. So that is the homework assignment. So if you can solve, so better to solve it and let me know what is the answer. So once you solve and end up with the correct answer, then it is okay. But whatever the answer you got, you need to write in the comment section, and then we will see if the answer is right or wrong.